Guys, Kush here, and welcome back to Allora DevPills. Last time we dove into how to set up a worker node using the basic coin prediction node that we've provided in GitHub. This time, we're going to take it up a notch. I'm going to show you guys how to manipulate this model by tinkering with different variables to make it truly unique. So let's talk about why this is important. Right now, most of the models submitting inferences on Allora are bare bones using the basic coin prediction node setup that uses linear regression to predict the price of a cryptocurrency. Due to the nature of how Allora works, models that use the same regression techniques will not be rewarded nearly as much as those that produce unique, valuable, and accurate inferences. In simpler terms, if everyone's doing the same thing, there's no innovation. On the Allora network, we reward innovation. If you're predicting the price of a cryptocurrency, it's not just about submitting the inference, it's about being unique and accurate. So, how do we make our model truly unique? It all starts with the variables that we want to choose and how we manipulate them. Let's dive into a few techniques you can use to start tweaking your model. One of the key variables you can change is the type of regression technique you choose to apply. Each regression model provides different insights and predictions based on your data and approach. So if we dive into our model.py file in our basic coin prediction node, you'll find 4 different models here that are separated by if-then statements in the train model function of the model.py file. This is the meat of your model. This is what's going to determine the regression technique that you use. And then that regression technique will be applied to the given cryptocurrency you choose in order to predict the price of that cryptocurrency in the future. The first model that we've offered is linear regression, which was also offered in the previous version of this basic coin prediction node. Linear regression is the most basic and straightforward model. It assumes a straight line relationship between input variables and an output. So it tries to draw a straight line between these variables and predict the future price of a cryptocurrency. It's quick and easy to understand, but it's not always the best choice if the data has twists and turns like a cryptocurrency. The second model we've offered is support vector regression. Support vector regression is a step up from linear regression. Instead of just drawing a straight line, SVR tries to fit the data within a certain boundary or margin. It makes it pretty good at handling data that's not just a straight line. And here's where the kernel trick comes in. SVR can transform the data into a higher dimension and then draw a line through that data to separate it and create more insights than just a simple linear regression model. It's like unfolding a crumpled piece of paper so that you could draw a straight line on it. This helps the model capture more complex patterns in the data that may not surface during linear regression. The third model we've chosen to offer is kernel ridge regression. It's very similar to SVR in that it also uses the kernel trick. However, it also uses a bit of regularization, which is a fancy way of saying that it likes to keep things simple and avoid overcomplicating the model. It's great for if you want a bit more flexibility, but still need to keep things balanced. The last model we've offered here is the Bayesian ridge regression model, which is a bit different than the other 3. Bayesian ridge regression doesn't just give you a prediction, but it also tells you how confident it is about that prediction. Think of it like a friend who not only predicts it'll rain tomorrow, but it'll also give you a percentage chance of how likely it is to rain. In our script, this Bayesian ridge regression model will still produce one output for each input, but it's a great tool when you want to know uncertainty around your predictions and factor that into your model. These are the different regression models that we've offered out of the box for you to use. And you can also use your own regression model of your choice and plug it into the model.py file here. Now let's dive into how to set your environment variables correctly and then redeploy your worker node accordingly. So now that we've gone over the different models that we could use out of the box in our basic coin prediction node, we're going to deploy our worker node to the network. But first we have to set our environment correctly using our .env file by setting the cryptocurrency that we want to use for a given model, as well as the regression technique and a few other variables. Let's dive into it. All right, guys, now that we've gone through all of the regression techniques that we provide out of the box for the basic coin prediction node, we're going to download the basic coin prediction node repo, set some environment variables, reconfigure our config.json like we did in the last tutorial, and then run our node so that it can send inferences to the Allora network via Docker. Let's get started. Let's copy over this Git repo and git clone inside a new terminal in our IDE. Now let's open this up in Visual Studio Code. Now we are in our basic coin prediction node. The first thing we're going to do is copy over our .env.example file into a .env file. Now let's open up this .env file and I'll run you through all of the variables so you know what to do. First variable to configure is the token. For different topics, there are different tokens. For this specific tutorial, we're going to use topic 1, which uses Ethereum as the target variable. So I'll set my token as ETH. The next variable is the number of training days, which is the amount of historical data in number of days that you want to go back and have your model trained on. For this model, I'm going to use 30 days. The next variable is the time frame, essentially the granularity of the data that you want. This can be split by 1 minute, 30 minutes, 4 hours, 1 day, really up to you. In my opinion, more granular data is going to create a better model. It's going to have more data for that model to play with, but it's also going to increase the size of your node in terms of gigabytes of usage. So you'll want to make sure that you have a GPU or some really strong server to run this on if you're going to use a large set of data. For this, I'm just going to use 4-hour data. The next variable we're going to set is the model. As we previously discussed, there are 4 models that come out of the box: linear regression, support vector regression, kernel ridge regression, and Bayesian ridge regression. For this tutorial, we're going to use support vector regression, SVR. The next variable is the region. We have 2 regions, US and EU. I'm going to use US. The last variable you're going to want to set is the data provider. We have 2 data providers out of the box, Binance and CoinGecko. For this tutorial, I'm going to use Binance because CoinGecko requires an API key. Save that, and now our environment is set. Next thing we're going to do is reconfigure our config.json file. So let's copy over config.example.json into a config.json file. As you can see here, the node RPC is already set for you for testnet. So the only 2 variables we need to set are the address key name and the address restore mnemonic. I have my key name and restore mnemonic set right here. I'm going to copy this over and paste it in. One thing to remember is that you need to request funds from the faucet with your Allora wallet ID before running your node, so that your wallet can pay for the registration fee as well as any transaction fees that it may incur when sending inferences to the network. Now that we got this set, we're going to run our chmod command, which will run a script that will load the config.json into our environment. Now we can run our docker compose command. Docker compose up -- build. What this is doing is downloading all of the dependencies needed for the node to run, downloading all of the data that you've set in your environment, 30 new files for 30 days. All right, our client was created successfully. Our worker node is already registered, which is awesome. But if you have a new node, it should say that your worker node is registered to the topic and a transaction will send. We're getting the latest open worker nonces now, which means that we've successfully set our environment, our config.json, and run our node. Awesome, guys. Thanks so much for tuning into this tutorial. I hope to see you next time on Allora DevPills. Catch you later.